So it's great that we understand what queuing is, but now we need to understand how we deploy it onto our network devices. In this video, we're going to explore all of the different options we have available to us, and then how exactly it looks when we deploy that onto UCS fabric interconnects. Let's take a look. In previous videos, we talked about this concept that on an interface, we'll likely have more traffic to send than we're able to send at a given time. And so what we end up with is we end up queuing up all of these different packets and sending them out in the order in which they come. This is known as first in, first out queuing, otherwise called FIFO. FIFO queuing basically does exactly what it says it's going to do. Again, the first packet in is going to be the first packet that gets sent out. So this is the first packet in, it will be the first packet sent out. This is the second packet in, it will be sent out second, and so on and so forth. And we talked about the problems with this. First of all, we can't guarantee any kind of bandwidth on this because if this packet back here, let's say this is the fourth packet in the queue, if that one really needs to be sent first, we have no way of reaching deeper into the queue and pulling it to the front of the line. We just don't have that available to us within a queue, and therefore if we only have a single queue, that packet's going to have to wait. Furthermore, the concept of having a priority queue. We can't actually prioritize traffic that we can't access either. And so with neither of these concepts available to us with FIFO queuing, you can bet we're going to want to deploy something else. Well, in UCS, that methodology is known as class-based weighted fair queuing, otherwise known as CBWFQ. In class-based weighted fair queuing, we can configure many queues, really however many queues that we want up to the hardware limit. Now on a Nexus device, and when I say Nexus, we should remember that architecturally speaking, fabric interconnects are also Nexus devices. These are usually going to support either 4 or 8 hardware queues. In the case of fabric interconnects and UCS, we're going to be talking about 8 different queues. Now to be clear, we can configure all of these queues, we can configure some of these queues, or we can technically configure none of these queues. Although none really is equal to 1, I guess I should have said 1 queue. At this point, everything goes into the best effort queue. And to be clear, this is absolutely not recommended. We do not want to rely on just a best effort queue in any environment, let alone our data center. Now, because we've created all these queues, we can assign bandwidth reservations to each one. So we can specify that, hey, the best effort queue, we're going to give you 25% of bandwidth, which is actually exactly what we want to deploy to best effort in most situations. And then we might say that our platinum queue is going to consist of, let's just say, voice over IP traffic as it traverses the data center, and because voice over IP traffic doesn't need a lot of bandwidth, we'll just reserve 10% of a link for it. And so as we discussed, we need to figure out which of our applications and which traffic types belong in each traffic class. Now we talked about the concept of a scheduler. The scheduler is going to be responsible for enforcing the bandwidth reservations. And we also recall that we are able to use the extra bandwidth if there's bandwidth available. In other words, if our platinum traffic exceeds 10%, but our link is only 50% utilized, well, the scheduler is going to enable us to send that traffic even though it's going to exceed the 10% that we reserved for it. Again, it's truly a reservation, not a hard limit. It does become a limit in times of congestion because if the link is congested, every other queue is going to get its allotted bandwidth, and therefore the platinum traffic will only get 10% at that point. But in times of not being congested, well, then that is just a reservation and not a hard limit once again. Now next, I want to talk about the concept of priority. We have the ability on Nexus platforms to configure what's known as a strict priority queue. Now, a strict priority queue is going to be a little bit risky because essentially what we're saying is if we've got, let's just draw out 3 different queues here, and let's call this a strict priority queue up top. So if I've got a bunch of packets lined up in these bottom 2 queues, and the scheduler is doing its thing and it's scheduling packets out according to bandwidth reservations, and then any packet arrives in this top queue, well, the scheduler is going to abandon the other queues and go straight to the strict priority queue and process that packet. And that sounds great, and that's very useful in the voice over IP world, for example. However, that does come at the risk of starving these other queues. In other words, if I have a steady stream of packets coming into this strict priority queue, and I'm constantly servicing these packets, I may never get to the other queues. And so I have to be very careful with the strict priority queue when I don't have the ability to limit the bandwidth. And on a Nexus device, we only have the ability to deploy strict priority queues onto our platforms. Now that said, while I want us to be aware of what a priority queue is, the fabric interconnects are architecturally Nexus and therefore they can support priority queuing. However, UCS Manager has it disabled. We don't have a way, at the time of this video at least, to enable strict priority queuing. I don't expect that to change anytime soon because it's been that way since UCS released. So just understand that if in our networking world we do have priority queuing set up, and maybe some other networking engineers are coming to us and saying, okay, we need you to push these priority queues down into the UCS environment, and the answer is going to be, sorry, we can't actually replicate that within the UCS framework. Now, I will say that generally speaking, inside the data center, we don't need a whole lot of this. Priority queuing was primarily built for voice over IP and video applications. And since we typically aren't deploying those technologies into the data center, then in a lot of cases we don't need them. However, again, if we do find we need those, then we can apply it at the Nexus level, just not within UCS itself. So now we come to this concept of configuration. How do I go about configuring QoS queuing and bandwidth reservations and such? Well, let me start with this idea of how we configure it on Nexus Gear. On Nexus Gear, we're going to use a concept called Modular QoS CLI, otherwise known as MQC. You may have heard of this or otherwise studied it because it's very prevalent on iOS platforms, and indeed Cisco migrated it into NXOS. And therefore, when we're deploying it, we're going to see some familiar commands, such as class maps, as well as policy maps, and service policies. Our class maps are going to define our queues, so we apply lots of class maps into a policy map. Our policy map is where we apply the policy, so things like bandwidth, for example, and then we map our policy maps to interfaces using service policies. Now furthermore, NXOS takes this a little bit further than what iOS does. We actually have different types of class maps and policy maps and service policies. We have, for example, type QoS. We also have type queuing. And lastly, we have type network QoS. And we are going to have to configure all of these in order to deploy QoS into a Nexus environment. Now that said, inside of UCS Manager, the way we do it is simply via the graphical user interface. We're going to see here coming up when we dive into the lab that it's as simple as logging into the GUI and changing the parameters on a single page. However, if we were to get onto the UCS CLI and we do that concept of connect NXOS, which is going to show us the underlying NXOS configuration, then we can expect to see all of this. We can expect to see class maps and policy maps and service policies, as well as the different types, the type QoS and the type queuing and the type network QoS. These different modular components of the CLI configuration are going to come together and deploy what we configure inside of the GUI. Now, the last thing I want to discuss here is the concept of packet drop. When we get onto UCS configuration, we're going to see this as an option for configuring. And this comes back to the idea of fiber channel over Ethernet. I'm going to explain this in a little bit more detail in an upcoming video, but the gist of it is that fiber channel over Ethernet needs to not ever drop a frame. And the reason for that is because the fiber channel part of FCOE, this is a lossless technology. We are not allowed to drop a fiber channel frame, and so we don't send a frame unless we know and understand that upstream is capable of receiving it. In the Ethernet world, I might send a frame up to this router, and there might be no way that it has room for it. It might be completely overloaded. And so I just send it and hope for the best, and of course that router is going to end up dropping the Ethernet frame. That's just how Ethernet works. However, that cannot be how fiber channel over Ethernet functions, and therefore, we've got to be able to kill this dropping mechanism, and the way we do that is with a technology known as priority flow control. Now, the reason I bring this up is because we are able to configure packet drop as part of our QoS policy. However, we need to make sure that we disable packet drop only for fiber channel over Ethernet traffic. Even though UCS does allow us to disable packet drop for any of our traffic queues, we need to absolutely make sure that we are reserving that for traffic that is going to use priority flow control and lossless Ethernet, which in most cases is only going to be our fiber channel over Ethernet traffic. So as we review this, class-based weighted fair queuing is how Nexus and UCS are going to apply bandwidth reservations in all of our different QoS configs. But at the same time, on UCS, we're only going to do that with the GUI. We don't need to worry about MQC configuration or anything like that. We worry about that in the Nexus space, and in UCS, we will log into the GUI and get it done. Now, as far as UCS packet drop is concerned, remember, that is primarily built for fiber channel over Ethernet. It turns Ethernet into a lossless fabric, and it's going to cause some weird behavior on Ethernet traffic that wasn't built around it. So for the most part, we want to reserve that for fiber channel over Ethernet and not deploy it to any other queue in our network. I hope this has been informative for you, and I'd like to thank you for viewing.